I am going to give y'all a little discussion or a little talk on cooling towers. Most refineries and chemical plants, pretty much all of them, have cooling towers. The cooling water is used. You're taking water out of the lake or river or wherever you're getting your water, the ship channel. That water is used inside of the units. It has to be treated. They normally treat that water with some kind of chemical. 9 times out of 10 it'll be chlorine. They use that chlorine to kill the algae and trying to minimize the impurities. So your water comes in from the river and it goes to this piece of equipment, a cooling tower. So let's talk about how a cooling tower works. You have a fan on the top. I can feel the fan is on. Now this fan would be what they call induced draft, because what we are doing, we are going to be sucking up. The fan is sucking up. It's inside of a shroud. Now the way that fan is made, it has 4 blades, and you have it's attached to a gearbox. That gearbox is driven by a motor. So as the motor turns, the fan turns. And now what they'll do, they'll go inside and they'll set what they call the pitch on the blades so they can get the right amount of airflow that they need to suck the heat up. Feels good right there. Okay, so what goes on, the water comes in from the river, like I said, or whatever you get in your water source. Water is chemically treated with chlorine. Then it comes into this cooling tower. So let me start this up. You just heard the pump kick on. Now the way it works, the water comes in and it's going to have a big feed line. That line is going to come up. It's coming up in the back of this one. And it's wiring off. You got 2 sides. You got a header here and a header here. These are called distribution headers. They have holes in them at the bottom of both sides. And the water comes in from the lake or river. It's treated and it's falling down onto what I call the top tray. On the very top, you have holes. And the water falls in and it hits these holes. And the water falls down through what they call fill. It would be the internals. Now, on the sides, coming in from both sides, you have what we call air louvers. And what the air louvers does is the fan is on, the fan is sucking air from outside, and the air is going up. So you got air coming in, flowing up. You got warm water flowing down. It's going to have that heat exchange. Now, as the water falls down, it's going through your field. What the field does for you, it gives you more surface area to allow for more cooling. Then the older cooling towers, the field is made out of 2x4s. In the newer models they're using nowadays, this is what the field looks like. Okay, so the water just drops in and it's going to bounce back and forth as it works its way down. Okay, so you have field like this in the newer ones, 2x4 in the old cooling towers. So, water comes in, air goes in, water going down, we got air coming up. Now, to minimize the loss of your water, we have what they call drift eliminators on the inside here, these white things. And what they do is, as the heat is pulled upward, you'll get your heat out, but you won't lose your water. That's the purpose of it. So the water bounces back and forth, the water droplets, it goes to what they call the basin. When it gets to the basin here, the water is cool. So you have a pump at the bottom. And on this suction of this pump, you're going to have some kind of screen or filter to take out the impurities. Some of these things, they've been around a while. You get trash in them. You get all kind of stuff, cups, wood, chips, or whatever. So that is sucked into that filter on the suction side. And it's going to discharge out of the pump and it's going to go back to your units to be used. So we got a closed-in system here. You got cool water leaving your cooling tower, going back to the units. It runs through your heat exchangers. It's going to exchange heat with your products in your heat exchangers, and it's going to come back from the unit through the back end. It's going to be hot, and you start the process all over again. What you're looking at right here, this is one cell of a cooling tower. I've seen as many as 13 different cells on cooling towers. So it would be what you see here 13 times in a row. We have the shroud with your fan. This would be one. and you'd have another one and another one and another one. And based on the temperature, outside temperature, your ambient temperature, if it is in the summertime with those 13 fans that we had, those 13 cells, I've seen as many as 10, 11 of them running. In the winter months when it's cooler, you need less cooling. So you may have 3 or 4 of the cells running. So that's determined by the unit engineer or whatever, whoever's calling the shots on that. As an operator, your concern is to make sure when you come in making your rounds, you want to check your pump, check your suction, your discharge pressure on your base pump, and you also want to go on top and you want to check your oil levels and your for vibration on your gearbox on the top, gearbox in your motor. Then basically in the winter months you have to be very careful because you do develop ice. So when you're going up, you have stairs leading from the ground to the very top of your cooling tower. Be careful on the steps and make sure you use caution when you're going up and down because there is a trip hazard. And a lot of cooling towers are built near roadways. So when you're getting a mist, I call it a mist, that's the heat and that's the condensation and your heat coming together. And that's gonna roll down to the ground. A lot of times the roads are very slick. So you have to be careful driving by cooling towers. And that's basically how they work. And you have to make sure of one thing, I forgot to tell you this. All water, these plants have to get a permit to state how much water they're going to use during that year. And the water has to be treated to make sure that you don't have a fish kill. You can't put, the water can come out of the lake and river. You have to put it back in at least in the same state. So it has to be treated to go back in. That's done by your wastewater operators. That's going to conclude our little discussion on cooling towers.